Hello friends, this video on rational numbers part 7 is brought to you by examfear.com. No more fear from exam. Now since then we have been talking about rational numbers. Now it is very obvious that something like irrational numbers must exist. That is why we have rational numbers, right? So when we talk about something called rational, that means there has to be something irrational also existing. Now when we talk about rational numbers, we see that all integers are rational numbers, all fractions are rational numbers. In fact, when you talk about the decimal numbers, we see that the decimal numbers with limited non-repeating digits. For example, let's say if you have a decimal number like this, 0.5. So here you have limited non-repeating digits after the decimal. Here after decimal you just have one digit. Or if you talk about 0.25, so you have limited number of digits after the decimal. So these are all examples of rational numbers, 0.375 and so on. These are examples of rational numbers. Or sometimes you might have endless repeating digits, for example 0.333333 and so on. What is this? This is nothing but 1 by 3. So if you ever try to convert 1 by 3 fraction into decimal, you would get something like this, where the 3 keeps repeating after the decimal. So these are also, they also fall under the category of rational numbers. But there are certain numbers which do not satisfy the criteria or definition of rational numbers, and they are irrational numbers. So normally these irrational numbers have endless non-repeating digits after the decimal point. So something like this. Now you would have come across this pi. So pi is nothing but 22. We take the approximate value of pi as 22 by 7. But please remember that this is just an approximate value. Just to keep our calculation simple, we consider the value of pi as 22 by 7. But if you actually convert this 22 by 7 into the decimal form, what do you see? You see that the value comes out to be 3.1415925 and so on, and it never ends. So basically in this case also it doesn't end, but you have different digits after the decimal. Like in this case you had the same digit repeating endlessly, but here you have different digits repeating endlessly. So these kind of numbers are irrational numbers because they can never be written in the form of p by q. Now you might ask, but it is written in the form of p by q, 22 by 7, but 22 by 7 is just an approximation of this value. So why we have done this approximation? Just to keep our calculations simpler. So pi is an example of irrational number. Similarly, if you try to find out the exact value of root over 2, so the value is considered to be 1.414213 and so on. So the value here also, it never ends. Now since it doesn't end and you have non-repeating digits after the decimal, you can never have an exact p by q form for that number. Therefore, these type of numbers where you have non-repeating digits endlessly after the decimal point, they all fall under the category of irrational numbers. So now in your higher classes, you will learn more about irrational numbers in detail. So for now, I think just an introduction, just to let you know that it is not only rational numbers that exist, there are certain numbers which are not rational as well. So looking at all of these, we found that there are certain criteria for a number to be rational number. First of all, it should be represented as p by q, where p and q are integers and q is not equal to 0. So that is the basic definition of a rational number. So that must be satisfied. All integers are rational number because all integers can be written as the integer divided by 1, which is in the p by q form. All fractions are rational numbers because all fractions, you think of any fraction where you say that fraction is also in the form of p by q, where p and q are natural numbers. Now when p and q are natural numbers, we know that all natural numbers are integers. So that means basically p and q are integers. And for fractions also it is a criteria that q should not be equal to 0. So basically this means that all fractions are rational numbers, but all rational numbers are not fractions. So I'll give you an example. Let's say you think of any fractional number, 37 by 2, or you think of 1 by 5. So all of these fractions are rational numbers. But when you think of a rational number like this, minus 1 by 3, this is not a fraction. You think of a rational number like 50. This is a rational number, but this is not a fraction. So all fractions are rational numbers, but all rational numbers are not fractions. Repeated decimals, for example, 0.3333 and so on. So these are also rational numbers. Terminated decimals, where you have limited number of digits after the decimal point, like 0.51, 0.45. So these are all examples of terminated decimals. So all of these fall under the category of rational numbers. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.